Good morning. Good morning. Okay, so I'm just going to sort myself out behind the scenes, make sure I've got some things. Whilst I'm doing that, you can have a little think about this question here and make sure you've got these things if you want to join in the activities today, GCSE Maths. I'm not sure that made sense, but I'm sticking with it. I'm not backing down. You're Maths. Okay, we're nearly ready, guys. If you want to head over to Facebook, there is now a space where you can say hi. If you would like me to say hi back during this lesson, don't worry if you've not got Facebook. You can just know that I'm saying hi to you too. Oh, some of you are on it. Some of you are on it. Like a garb on it. I don't know if that's a real thing. Oh dear, I'm in a silly mood. Right, are we ready? Have we got everything? Let's do the checklist. Yeah. Good morning, Maths Mom! I've done the checklist. We're good to go. How are you doing this morning? My name is Ruth. This is Joyful Maths with Ruth, and you are here live. Or maybe not if you're watching the recording. You are maybe not here live watching this lesson, which is designed for Foundation GCSE Maths or Functional Skills 1 or Functional Skills 2. We're covering all of those at the moment. This covers all exam boards on Foundation Maths. So that's not the Cambridge IGCSE because it's not split into Foundation and High. So anything else though, anything else. I say Edexcel, but it works for all of them. Okay, so I asked you a question. I started off with a picture and I asked you a question. I'm going to be honest. I'm going to be upfront. I'm going to be honest. It was a bit of a trick question. I was being a little bit mean here. Somebody actually gave a really good answer on Facebook the other day. The perimeter is 12 centimeters. What is the length? The honest answer is we don't know. There is an infinite number of answers because the perimeter is the measurement all the way around the side of this shape. But we haven't got enough information to answer this question at the moment. To be able to calculate the perimeter of a rectangle, we need the length, which will also give us this length, but we need the width as well so that we know those two lengths there. So once we've got those, we can add them up because perimeter is walking around the outside of something. So we would need the length, the width, the length, and the width again. So we can't find out the exact length of something if we have not been given the width as well. Okay, so we're going to start off by just getting our head around what perimeter actually is. Some of it I've observed a few times, many hundreds of times, people not being sure about which is perimeter and which is area and getting their head around what those mean in terms of the language and the mathematical meaning. So we're just going to get our head around what perimeter is first. If you have got a tin of some form, so I've got coconut milk, which is exciting. I made a lovely soup with this yesterday. Yes, the recipe is available if you ask me. But it's all seasonal. We did it pumpkin soup, although probably coconuts not seasonal. Yeah, ignore that. We're going to measure the perimeter of this tin. Now, this is a 3D shape. We can't measure the perimeter of a 3D shape. It's got too many dimensions. So we're going to look at the circle. The circle that is on the top of the tin, we're going to measure the perimeter of that. So I asked you to bring some string or some wool, something that you can wrap around it essentially, and then we can unwrap again so we can see what this looks like. I've got my string here, and you're going to need some scissors. Okay, right, let's just adjust the angle of this so you can see what we're doing. We're going to take our tin, and the perimeter is the distance all the way around it. So I'm going to take my piece of string. I'm going to hold it down at one point, doesn't matter where it is, and wrap my string around my tin. Wrap it around. And then where it joins up to the start again, I'm going to mark it. I'm just going to do that with my finger. Oh, she says not doing it very successfully. Let's try that again. I'm going to mark it with my finger. There. And then we're just going to snip that off at that point. Snip that off. Oh, I've got wax on me. Things. And then what you might notice is that this piece of string is no longer a circle. We can make it back into a circle. We could turn it into a square. We could turn it into a triangle. We could turn it into a rectangle. We could turn it into any shape we like. Because the perimeter actually just represents a length. We can pull it out and show that we have got a length of string there. So perimeter is actually representing just a distance or a length around something. And we can measure that. We can just grab our ruler, show you on the floor, and we can measure it. So again, I'll just adjust this a little bit. So I can take my ruler. I can lie my piece of string out flat, one end right bang on the 0. And then I'm going to lay out the other end like this, just like that. And you can see that's just under 23 centimetres. Just under 23 centimetres, mine was. I wonder what yours is. Is yours the same, similar, slightly longer, slightly shorter? We might have differences in tins. Also, you might have difference in stretchiness of your string if you're pulling it tight. So that's the perimeter of something. But you'll notice that was the perimeter of a circle. We want to look at rectangles today. So I was thinking, like, what do we have that we can hold that is rectangular shape? And I was hoping most people would have some sort of book. This is actually a book I'm reading at the moment. It's not quite what I expected. I thought it was going to be more of an actual adventure, but it's still really cool. Lots of math stuff in there that I'm enjoying. So we're going to measure the perimeter of this book, this rectangle shape here as well, using our string. So we're going to go around it, and it's just like going around the perimeter. Well, just like walking around the perimeter of something. We're going to use our oh, where have I dropped my string? Are we going to use our string? Are we going to do this, Ruth? Oh, well, that'll teach me for just chucking stuff on the floor, won't it? Here we go. So what I'm going to recommend is starting at a corner. So start at one corner, and we're going to go along the length, and then we go down the width, then along a second length, and then along a second width. So that when you go, you've then got back to exactly where you started. And that is our perimeter of a rectangle. We're going length, width, length, width. And because we are going to add these together to get a full length, so when you untangle that, again, you will end up with a length of string, because we're adding them together, and you can add in any order you like. Adding something called commutative, you can put it in any order. It actually doesn't matter what order we add those up in. We're going to get the same length piece of string there. Okay, let's have a look at applying this to a problem and what we need to know for perimeter then. So I've got a football pitch here. I've looked up the actual length and width of a football pitch. For some reason, I didn't keep them in feet, which is what they gave me them. I decided to convert it all into meters. So what do we need to know to find the perimeter of a football pitch? I'm going to give you a second just to think about that. What information do we need to be able to answer this question? I appreciate on here that you cannot answer, but what I'll do is use answers from Facebook that I did on Tuesday to assume. I know you should never assume, really, should you? Assume the answers you're giving me. But feel free to shout it at the telly. What information do we need to know? So I think you may be telling me we need the length and the width. So we need the length and the width, and you are absolutely right. We need the length and the width. So the width of this football pitch is 36 meters. The length of this football pitch is 55 meters. What is the perimeter? So have a go at calculating the perimeter now. What would you do to calculate the perimeter of that football pitch? So if you've got the workbook, you can do it in there. If you're working on a piece of paper or whiteboard, do it on there. If you feel you can do this in your head, do it in your head. That's absolutely fine. Whatever works for you. Okay. So there are multiple different ways of doing this. So I'm going to go through a few different methods that you can use to calculate the perimeter of a rectangle. So the first one is to go around it like I was showing you before. So you go length, which was 56 meters. No, sorry, it was 55. I'm not going to write the units on every single time because it just gets a bit of a lot of writing. So we could go length plus width, which was 36, plus length again, plus width again. And we can add it up exactly in that order. So 5 and 5 is 10, 6 and 6 is 12, so that's going to give me 22. And then I've got 5 and 5 is 10, 3 and 3 is 6, so that's 16, plus the 2 gives me 18. So I end up with 182, and in this case, it's meters. We saw it was the length, so we keep it as meters. Okay, but you may also have spotted, well, we're adding together the length and the width, and then we're doing it twice. So we could have done 55, the length, plus 36, the width, and then just doubled that. So we could have just doubled that answer. 55 plus 36 gives me 91. Double that answer, and we get exactly the same again, 182 meters. Or you may have done something like where you spotted there was 2 lengths and 2 widths. So we take the 55 and we double that. And we take the 36, we double that. And then we add them together. Again, you're going to end up with exactly the same answer. Lots of different methods. There's not one that is like the right method and one that's the wrong method. You can use any that works for you. It's nice to explore multiple different ones though, because in different situations, different ones can be easier to use. Okay, using that information then, we're going to play a little game. You're going to be a detective. You're going to find the missing information. So I'm going to give you a rectangle and I'll give you 2 pieces of information. I'll give you 2 of the following: the perimeter, the length, and the width. And I want you to find the missing one. Okay, so I'll show you on the first one. Here, we've got a blue rectangle. The width is 13 centimeters. The length is 4 centimeters. So for this one, I want you to find the perimeter, please. Can you find the perimeter? I never know how long to give you these. I don't want to rush you. So, but also I'm aware, we want to keep it going a little bit. So, you know, if you manage to do 2, there's 4 of these. If you just manage to do 1 or 2, that is absolutely perfect. I'm going to give you the second one now. So here, the width is 3.3 millimeters. The length is 2.5 millimeters. So can you find, again, the missing information we've got here is the perimeter. Can you find that? It should have said you can do these with or without a calculator. It was absolutely fine. Okay, I'm going to give you the third one now. So we've got a red rectangle. I've given you the length. I've given you the perimeter. Can you find the width? And I'm going to give you one more. Last one, the purple one. I've given you the width. You've got the perimeter. Can you find the missing length? Okay, let's have a little look at these then. So again, don't worry if you've not finished them all in that time. That's not a problem at all. This is all about the understanding. The practice can then happen later. That's not a problem. So perimeter, we need to go all the way around the edge. I can spot that we've got a length of 13 here. So this side is also going to be 13. We've got a width of 4. So this width here is also going to be 4. So I'm going to do 13 plus 13, which I know is 26, plus 4 plus 4, which I know is 8. So I end up with 26 plus 8, which ends up giving me 34 centimeters. Was it in centimeters? I think it was centimeters, that one. Let me just check. Yeah, it was centimeters. So that one ends up being 34 centimeters. The next one we're also found in the perimeter, so we've got to go all the way around the edge. I can do the same sort of thing again. I can identify that this side is also going to be 2.5 and this side is also going to be 3.3. Or I could add these two together. So I could do 2.5 plus 3.3 and find out what that is. So 5 plus 3 is 8. 2 plus 3 is 5. That's an awful 8 there, isn't it? And then I know I'm going to have to do that twice. So now I double it. 5.8 and I double that. And it gives me 11.6, in this case, millimeters for that one. In an exam situation, sometimes they ask you, they'll give you the units like millimeters. Occasionally, like 2 or 3 times, they'll miss them out. And then you can gain marks from doing that. So do put them in if they're not there. The next one, we had the perimeter, but we didn't have this missing width here. So to do this, I need to identify the information. I do know I know that this top line here is also 4 centimeters. So if I travel along that line and that one, it gives me 8 centimeters altogether. 4 plus 4 equals 8. So I know that 8 centimeters of this 14 is covered. So I'm going to take that away from my 14. And I'm left with 6 centimeters that I'm going to have to share between the other two sides. I know they're exactly the same. So I'm just going to half it. 6 divided by 2, which gives me 3 centimeters for that missing width. Final one, we had a missing length. This one again, I know that this side over here is also 11, so I can use the same logic for this one as I did for the first one. 11 plus 11 is going to give me 22. I know I can take that off the 27 for the full perimeter to see what I'm left with. So I will do 27, take off that 22, leaves me with just 5 centimeters to share between the two missing ones that I have there. So I would have to half 5 or divide it by 2. I can write that as a fraction like this or using a divide sign. So it was 2.5 centimeters in that case. So the missing one was 2.5 decimal in that case. Or you could have written it as a fraction too. That's absolutely fine. Okay, we're going to have a look at a bit of area now. So I asked you to bring some paper with you. I asked you to bring some A4 paper. We're going to turn that piece of A4 paper into a square to start with. Oop! Exciting, exciting. Thanks, webcam. I like a little bit of moving around. So you've probably done this before. You take an A4 piece of paper, and what we're going to do is we're going to fold it to create like a triangle, and then cut a bit off to create a square. If you've not done it before, I'll show you a bit more accurately now. I'm just going to shift it. Oh, no, you are going to stay there. It's not actually up to you, webcam. You do as I tell you. I am the boss. She says, hopefully. So I'm going to take this top left-hand corner here, and I'm going to fold it down so that the top edge is meeting this edge on the right here. And we fold it to create a triangle there. And then you're just going to cut off this bottom edge, and you should be left with a square. So if you just cut off this bottom edge here, you'll be left with a square when you unfold it. Okay, and the square is what we want for this. We're looking for a square. And then we're going to use this to talk about area. So whilst I'm doing this, I'm going to shift you around actually. We're going to go back to our football pitch. So if we have a look at this football pitch here, we talked about the perimeter, which was walking around the edge of it. Now the area, I like to think about this in terms of how much grass do we need to cover this pitch? And that would describe our area, how much space is within that rectangle. So that's no longer going to be measured as a length. We couldn't use a piece of string to wrap around that. What we're going to do is actually split it up into little squares, which hopefully you can see on here. I've not done this perfectly, but the idea is that I would split the width up into 36 strips across, split the length up into 55 strips going up, and then we're left with these little squares, and the area is going to be measured in little squares on there. So I'll talk a little more to that in a second. Hopefully you've got your big square of paper now. We're going to turn it into some smaller squares. So once you've cut that, you're just going to unfold it so that you've got a square. And then we're going to turn this into 16 little squares. We're going to do that by taking our piece of paper, and we're going to fold it down in half. And then we're going to do that again. So we take this top edge and we fold it down again. Like that. Okay, and then we can unfold it. So we've folded it down again. Okay. And then we're going to do the same from left to right. We're going to fold. Oh, well, I'm going right to left actually, aren't I? Fold. No, I'm not. I am doing left to right. I'm upside down. I have to remember that. Okay, we're going to fold across in half. And then we're going to do that again. Fold that again. And what you will have created on your piece of paper is 16 little squares. Can you see those? 16 little squares, and you're going to cut those out into individual little squares so that we can use those for our next activity. So lots of cutting, yeah. So cutting those out to make the little squares. I'm going to talk to you whilst you're doing that a little bit more about area. A little bit more about area. I did this on Tuesday, so I'm just going to use my little squares from there because multitasking is not my forte. Okay, so here I'm going to show you a little more accurately what I was talking about with the area of the football pitch. So I can do this precisely now because I've got numbers that I can work with on the screen a little bit better. The width is 2 centimeters. So I'm going to split that up into 2 separate strips that are the same width as each other. The length is 4 centimeters. So I'm going to split this up into 4 equal sections that are all going vertically. Split that up into 4 sections. And then in this case, because I've used such low numbers, I can count the squares. 1, 2, 3, 4, 5, 6, 7, 8. But if we went back to our football pitch, it would take us a really long time to count these squares. So that's not a very useful method. So another way of calculating this would be to take the width, which is 2, take the length, which is 4, and multiply them together. If we do 2 multiplied by 4, that gives us 8, which is our area of our rectangle. So here we're going to be multiplying them together. The formula for the area of a rectangle is width multiplied by length. Okay, I'm hoping that's giving you enough time to count, to cut out your 16 squares. Hopefully. What we're going to do is take 12 of those squares now and have a little experiment with them. I'm hoping you can watch me do this. So we're just going to take 12 of them. And see how many different rectangles you can create using these. Now we can call them centimeters squared. I've just called them units squared because I'm not sure how big they are. But if I put these together, I'm using exactly 12 every single time. I could put 3 across the bottom, and then I could do another 3. Okay. Ooh. And then I could do another 3 and keep going until I've made a rectangle with 12 of these squares. Okay, so that would be my first rectangle, and it's got a width of 3 and a length of 4. And I want to record that some way. So a couple of different ways you could record this. You could do it through a little drawing, or you could just record the length and the width. So if you want to do it with a drawing, you would draw out the rectangle like this, and you would label it 3 and 4. If you just want to record the length and the width, we could just write 3 multiplied by 4 equals 12, because that's what the calculation we're doing here. Okay, your challenge now is to see how many different rectangles you can make with 12 of these little squares. So how many different ones can you make? So I've given you one. How many different ones can you make? Okay, always using 12 squares. So I'm going to flip that down there so you can see what I've done. So you've got that as an example. Whilst I write out the different ones I think I can make. So I can show you. So moving these around, can you make some different rectangles? So once you've recorded it, you would take all these apart and start a new rectangle. Yeah. Leave that one on there so you can see that one. Does anyone take it and do a 2 by something rectangle? Can I fit it on? Just if I hold those ones. And then I'm wondering if anyone's done a really, really long rectangle, which I think I'm going to have to do across like this. Let's see if I can do it. See if I can fit it on. I think it's going to go off the screen. Did anyone do a super long one? Oh, I've had to make it go to my laptop. Did anyone do a super long one? Can you see that? Like that. Super, super long. And you may have even noticed some more. Okay, let's have a look at the ones I've done. So we have, this is the one I showed you, 3 by 4. 3 by 4. But some of you might have noticed, well, I could just take that rectangle and just switch it around like that. I could just turn it on its side, and then I've got a 4 by 3 rectangle. I could just switch them over, and you're spot on. You could. They are essentially the same rectangle. It's just been rotated around. But we absolutely can do that. Multiplication, like addition, is commutative. You can write it in either order and get the same answer, which is really nice. So we could have had a 3 by 4 and a 4 by 3 rectangle. Similarly, you may have noticed you can get a 2 by 6 rectangle, and we could rotate that one around and get a 6 by 2 rectangle as well. And then the super, super long one. We've got a 1 by 12 rectangle, which we could also rotate and get a 12 by 1 rectangle. And if you're if you want to take this really far, you could actually start splitting up these squares. I think I did this the other day. You could take a square, for example, or you could take all 12 of them and cut them all in half. And you could make an even longer rectangle where the width is a half. So the length is going to end up being even longer. So there's actually an infinite amount of possibilities with this if you want to start going into fractions and decimals. But I did tell you just to stick with the square. So, you know, that is my bad. I'll take that one. All right, let's have a little look at this. I'm going to get another piece of paper, and you can watch this one or join in. It's entirely up to you. So I've measured a piece of A4 paper, and it is very roughly, it's not exact this. I've done it to the nearest centimetre. 21 centimetres by 29 centimetres, okay? First of all, I want to know from you, what is the area of that A4 piece of paper? What is the area of an A4 piece of paper? You can absolutely use a calculator for this. Okay, you can absolutely use a calculator. Right, so I'm just going to turn this on. So if I'll show you a piece of A4 paper. I'm telling you it's 29 centimetres in width and 21 centimetres in length. What would the area of that be? I'm going to pop it into my calculator now. I'm going to pop that into my calculator. And then I'm going to do something. I'm going to do something to it. So keep that answer somewhere. What I'm going to do is I'm going to cut a hole in my rectangle. I'm going to show you this now, and then I'm going to do it. So I'm going to cut a hole into this rectangle that is also a rectangle. So I'm going to cut a 5 by 10 rectangle into my piece of paper and then remove it. And I want to know what the new area of my piece of paper is going to be. What is going to be the new area of my piece of paper? Okay, I'll leave that there for a second. And then I'll show you me doing it, and you can have a go at the calculation. What will be the new area of my piece of paper? Okay, I'll turn this around. Okay, a little dance? Let's have a look. Oh man, come on, webcam, work with me today. Hey, I thought we were friends. So this is my piece of paper. I'm going to draw my new rectangle on here. I'm going to draw. Doesn't matter where it is. I can put it anywhere. I can draw 5 centimeters for the width and 10 centimeters for the length. And then I'm going to join it all up to make it a rectangle. Like this. So this is 5 centimeters. This is 10 centimeters. I should put centimeters on there. And I'm going to cut that section out and remove it from my rectangle. I've got one that I did the other day. I'm going to show you that. So I had that in there. I'm going to remove that section out. And I want to know what is the area of this bit of paper that is left over. What is the area of this bit of paper here that is left over? Okay, let's have a little look. Oh, where did I put that? So for this, when it was still a complete piece of paper, hopefully we did 21. Oh, writing upside down. What am I doing? Hopefully we did 21 multiplied by 29 to get the total area, which was 609. And the units for this are going to be centimeters. Let me write a C properly. Centimeters squared, because we're measuring these in squares. Like the squares that we created are not in lines. It's not length. So that was our full rectangle. Now we've got this rectangle and we're going to remove it. So I want to know what is the area of that new rectangle. So I'm going to do 5 times 10. Keep forgetting I'm writing upside down. 5 times 10, which gives me 50. And again, that is an area. So it's centimeters squared. And because I've removed it out of my rectangle, I'm going to take that away. So I want to do the 609, take away the 50. So 609, take away the 50. Oh, line that up properly. And that's going to leave me with 559. And that's still centimeters squared, because we're still measuring that area in little squares. So then my next question to you is this. If I reattach this somewhere around the edge of my piece of paper, so if I reattach that there, what would be the area of my rectangle? What would be the area of my piece of paper, I should say? If I reattach that anywhere around the edge of this piece of paper, what would be, what would be the area of my piece of paper? Are you shouting 609? Yeah, absolutely. It would be 609 because we've reattached the bit that we took away. It would go back to being 609 centimeters squared again because we've reattached the piece of paper. Okay, right. Last little problem for you then, linking to area. This is from an amazing website called Transom. I absolutely love this website. And you can find it just by searching for Transom area maze. This is a rectangle. I've got, it's a compound shape it's called, because it's made up of 2 rectangles. So we've got a purple rectangle and we've got our blue rectangle. So the area of the purple rectangle is 6 centimeters squared. The area of the blue rectangle is 10 centimeters squared. And I know that this width here is 2. I want to find out this missing length. What do you know? And what could you work out here? What do you know? And what could you work out? one of the things you might be able to work out is the total area. And that might be something you find helpful here. What do you know? What can you work out? Can you find that missing length using the information you've got? Shall we have a little look together? Shall we have a little look? Okay, so I'm hoping lots of you did find that total area. That total area is definitely going to be useful to us. So at the moment, what we can see is the two rectangles together are creating a new rectangle. They've got this shared width here. So we can actually we can combine this area by doing 6 plus 10 to get the total area. So 6 plus 10, I know, is 16 centimeters squared. This is what I love about whiteboards. You can just rub bits off as you go rather than redrawing it. The other thing I know is that to find the area of a rectangle, I do the length times the width. So I'm going to do 2 multiplied by something that we don't know, and that's going to give me 16, which is the area. Now, you might just know what goes in there, or you might need to work backwards and do the inverse. The inverse is the opposite to this multiply here, and the opposite to this multiply is to divide by 2. So if we do 16 divided by 2, it gives us 8, which is going to be our missing length, which is going to be 8 centimeters along here. And that is a length, so that's a centimeters. So only the area that's measured in the tiny little squares. And we can check it. We can say, does 2 times 8 give us 16? It does, so we are spot on there. If you've got the workbook, I did pop another one of those on the workbook for you to have a go at. I'm going to leave that now because I do want to make sure we've got time for the quiz. And I've got time to say hi to people as well. Okay, the quiz is 4 questions. And they're all multiple choice answers. When you pick your answer, you're going to pick the letter that goes with it. And at the end, we should have 4 letters that you can rearrange to make a word. Okay, first one. So here, I'll show you with this one how we would answer this. The perimeter of the rectangle is, so I've given you this purple rectangle with the width and the length. And if you think the perimeter of this rectangle is 8 meters, you would pick T as your first letter. So that's the first question. The perimeter of this rectangle is, and then you choose whichever one you think is the perimeter of this rectangle. Okay, second question. The width of this rectangle is, so I've given you the perimeter here, and you're choosing A, B, or C. Which one do you believe to be the width of that rectangle? Do make a note of the letters as you go. Third one, the area of the rectangle is, so I've given you this yellowy orangey rectangle here with the length and width, and you've your job is to choose which one do you believe is the area of the rectangle, A, B, or C. Make a note of the letter that you think has got the correct answer next to it. And the final one, the fourth question. We've got this blue rectangle here. It says, oh, this has jumped a little bit. The area is 28 meters squared. And I want you to find this missing length here with a width of 4 meters. Is it D, is it E, or is it F? And then hopefully you have got a 4-letter word there. Well, you've got 4 letters and you need to rearrange them into a 4-letter word that might have something to do with the lesson. Maybe? Okay, let's have a look at these. So the first one you will find in the perimeter. It was a 3x5 rectangle. Many different ways to find the perimeter. We could do 3 times 2, which gives us 6 because we've got 2 of the 3s, 2 of the 5s. So we do 5 times 2 gives us 10. And then when we add those together, we get 16 centimeters. So for that one, you should have got an R, letter R. For the second one, we were given the perimeter, which was 22 meters. We were given the width, which was 6 meters, and we wanted to find the length. Well, we know this side is also 6 meters. So we're going to do 6 plus 6, which gives us 12. And we want to take that off that 22. So 22, take that 12, which leaves us with 10 meters, which we've got to share between the 2 widths. So we would have to do 10 divided by 2, which leaves us with 5 meters for each of the widths. And that should have given you an A for that one. For the third one, we were finding the area of this rectangle, a 7x5 rectangle. Area is length times width. So we do 7 multiplied by 5, which gives us 35 centimeters. Oh no, this one's meters squared. And that should have given you another A. Another A. So we've got R, we've got A, we've got A. The last one, I was giving you the area was 28 meters squared. I'd given you the width was 4 meters, and we needed to find this length here. So we know 4 times by that missing length gives us 28. And so we need to do the inverse to work out what the missing length was. So it's 28 divided by that 4, which gives us that missing length of 7 centimeters. And that one gave you, oh no, again, it's meters. I keep putting centimeters automatically, but it's meters. And that should have given you an E. So you should have an R, an A, and an E. Hopefully you can rearrange that into a word from today. Did you get area? It sometimes works. Hopefully you got area. I tried to check. I thought about it. Do the letters spell anything else if you pick different letters? I couldn't see one, but it could be funny if you got a different word to me. Anyway, right, that is the end of today's lesson, and that is actually the end of this half term. Next week, I have like a week of planning, so I don't do any lives next week. So we'll be back in 2 weeks' time. for another live lesson. I will do the hellos in a second. I do need to let you know how I get paid for this job. So the lessons go out for free. And then I get money towards my wage from these lessons by people signing up for £5 or £6 a month to support them. And that pays towards all the hours that I put into the planning, the advertising, and the doing of these lessons. And I say thank you to those people by sending out a booklet all about some cool area of maths or exploring maths in a cool way. This one's for activities, which is a really cool area of maths I love. It's got quizzes, things you can do, games you can play in it, and it comes with some beautiful origami paper and some stickers that I designed as well. And really exciting is that this week I'm sending to the printers my next booklet all about weather, and I'm very excited to get that out too. Okay, I said I promised some highs. Are you ready? Guys? Okay. Hi, Bertie. Nice to have you here today. I love that name, Bertie. Before I got married, my name was Ruth Gilbert, and my brother used to get called Bert quite a lot because of that, because of our surname being Gilbert. So yeah, I like the name Bertie. Who else have we got? We've got Otis. Hi, Otis. Nice to have you here too. Jacob. Always on it, Jacob. Nice to have you here. And Lewis watched the recording from earlier in the week as his grandparents are joining you in Fuerteventura. Have a nice time, Lewis. I hope you're having an awesome time with your grandparents. That is a lovely reason to not be here. Okay, I'm going to just do one quick refresh, so make sure I've not missed it out. But also those people that have not got Facebook, I want to say a special hi to you guys. You do not need to be able to say hi on Facebook. Okay, I think I've got everyone. Awesome. Thank you so much for joining me. I will see you, unless you want to join me for Maths and Dinosaurs, of course, live at 11:30. I will see you in 2 weeks for the next GCSE/functional skills maths lesson. Bye for now, guys.